Interpret the meaning of values of exponential functions. The first U.S. census was conducted in 1790. The function p of t equals 3,929,214 times 1.0203 to the t power represents the population p of t for t years after 1790. So we're going to answer the two questions. What is the meaning of the a value? And what does that 1.0203 represent? So first, let's take a look at a generic equation for exponential functions. Here we have f of x is equal to a, which is our initial value, times b, which is our growth or decay rate, to the x power. Well, we have an equation that looks like this in our word problem, that p of t equals 3,929,214 times 1.0203 to the t power. Well, where that a value is, we have that 3,929,214. Well, if we look at this problem in the context of how this equation is used, that number is going to represent the initial value, but what are we counting? Well, it says we're using the U.S. Census. And what the U.S. Census does is it counts the number of people who live in the United States. So we can say that this a value means that at the first census, there was a population of 3,929,214 people in the United States. Next, let's look at that b value. Our b value here says 1.0203. But what does that mean? Well, if we look at that number, I know that it's going to be a growth because that b value is greater than 1. So we're going to set b equal to 1 plus r. But b we know from the problem is 1.0203. So 1.0203 is equal to 1 plus r. So if I subtract 1 from both sides of that equation, we get r equals 0.0203. I want to pull up my pointer here. I want to point at this decimal place. So this point here, if I move that decimal 2 places to the right, that's the shortcut trick to change it from a decimal to a percent. So we can say r is 2.03%. So we can say the population grows, because we said it was a growth, at a rate of 2.03% each year. The next question says the graph below models the amount of caffeine in a teenager's system in terms of A of x, the milligrams of caffeine in the body, and x, the amount of time in hours after drinking a cup of green tea. So we have two questions here. What can we say about the amount of caffeine in a teenager's system after they drink a cup of green tea? And how much caffeine is in a cup of green tea? Well, again, we have that generic function, f of x is equal to a, that initial value, times b, our growth or decay rate, to the x power. So first, I want to look at this graph. I'm going to grab my pointer one more time. If I follow this graph from left to right, because we read a graph from left to right, notice as the x values increase, that's when we go right, the graph is decreasing, it's falling. So we can say the amount of caffeine in the system of a teenager decreases over time. Well, how much caffeine is in a cup of green tea? Well, remember, when we drink the tea, that's going to tell us how much we have in our body. So that initial value there, 35, is going to tell us that we start with 35. Well, 35 what though? If I look at my question, back to our context, that A of x tells us the milligrams of caffeine in the body of a teenager. So we're starting with 35 milligrams. So once you've drank the cup of green tea, that's all of the tea. So we can say there's 35 milligrams of caffeine in a cup of green tea.